In this training video, we're going to be looking at Agilent's N9330 cable and antenna analyzer. In the past, you may have seen or used older instruments, such as this old SiteMaster I have here. The N9330 has all the same capabilities, plus a few extra, but in a much more modern instrument with a bright daylight. Pinched or damaged cable, typically occurring sometime after installation. Lightning damage, fire, corrosion, and other natural effects. The way it works is that the N9330 sends a signal up the cable and listens for any reflections coming back down the cable. In a perfect installation, there will be no reflected signals. But wherever there's a fault, some or all of the signal will be reflected back down the cable. The N9330 looks for these reflections, works out how far along the cable each fault is located, and shows us the results on the display. And I now have a choice. I can either calibrate directly onto the Type N test port on the top of the instrument, or what I'm actually going to do is calibrate on the end of my fly lead. And now all I have to do is press Cal and Enter. The unit automatically detects that I've connected the electronic calibrator unit, and without any interaction from me, it automatically goes through and calibrates. On the x-axis, you can see that we're sweeping from 25 to 300 megahertz, and on the y-axis, we have a return loss from 0 down to 60 dB. Now I can immediately see that we have a problem with our cable and antenna system here. All of these wavy lines on the screen show me that we're getting multiple reflections up and down the cable. Now, as you know from our theory, the antenna should be resonant at a particular frequency, which is the main dip in the curve you can see there. But other than that, the cable that links the instrument to the antenna should behave like a perfect transmission line. In other words, it should be totally invisible to the instrument and to this measurement that we're making. So there's something not quite right with the system. It's either going to be a fault with the cable or some of the joiners, but we know definitely that there is an issue. So what do we do to investigate it further? I've now connected the antenna directly to the test lead of the instrument, and you can see on the screen that all of those ripples on the trace have now disappeared. So I've reconnected the antenna to the analyzer, but via the 13 meters of RF cable, and you can see that because we have the ripple back on the trace again. So I'm going to press the mode button and select one of the distance default measurements, in this case return loss. I'll stick with return loss for now, and press enter. You'll see on the very left hand side of the screen here, there's a large yellow trace. Now you can see that marker 1 is at 0 meters and has a return loss of 14 dB. Now that's a very large reflection from what's supposed to be a perfectly good connector join. So that tells me that either the connector is faulty, or it's not been installed correctly, or there's some water ingress at that point, any of those different possible faults. But that's one immediate issue that will have been causing the ripple on the frequency domain trace. In this final section of the video, I'm going to run through all of those really useful features that the N9330 has that will make your life so much easier when out in the field doing actual measurements. But let's get out of that, and instead what I'm going to do is press the Mesh View button and press a button called Trace Overlap. This allows me to overlay or overlap the live trace against or over the top of a previously stored trace. So I press the Select Trace button, select the one that we've just stored, press the Enter button, and you can now see that we have the live trace and the previously stored trace shown at the same time. One is in green, one is in yellow. If I now make some changes to the live trace, for example by touching the antenna here, you can now clearly see that we have both the green and the yellow live trace shown on the screen at the same time.